Now let's demonstrate how to calculate the total area under the curve. Total area under the curve. Draw a graph. It is x-axis and it's our y-axis here. And this is a graph of our function f of x. Now there are two ways to calculate this area under the curve. One is the Riemann sum and the other is the integration. Let's first take the Riemann sum. For the Riemann sum, distribute this area under the curve into rectangles. For instance, we have 3 rectangles. And what we're going to do here, we're going to find the area of each and every single rectangle, and then we add all those areas to get the total area under the curve. The area of a rectangle is height times width, is the area of the rectangle. These are the points x1, x2, x3, x4. And this is the weight for the first rectangle, and it is the height, width, and height for the second rectangle, width and height for the third rectangle. Let's take the first rectangle. The area for the first rectangle is height times width. Our width is x2 minus x1, which is our delta x. This is our width. Now take the second rectangle. The area of the second rectangle is height times width. Now take the third rectangle. The area for the third rectangle is height times width, and it is called the Riemann sum. This I is the number of rectangles start from 1 to the desired number of rectangle. Y sub I is the height along y-axis, and delta x sub I is the x-axis, is the width along x-axis. One thing you have to remember, it is not the accurate and easy way to find the total area under the curve. We can see here that we left empty space at some places, and this has to be calculated. Now the more you have the number of rectangles, the more you're gonna close to the total area. Let's increase the number of rectangles here. We double the number of rectangles. Now we have 6 rectangles, and we can see here that we have less empty space compared to the previous one. Increase more, still we have empty space that has to be calculated, and increase some more. Now approximately it is the total area under the curve, but still we have space, you can see here. And the only way to get the total area is to increase the number of rectangles until you get 0 at x-axis. It starts from 1 and up to the infinity. It can go, and as usual this is the height and this is the width. But there is one alternate way which is very simple, very straightforward to find the total area under the curve, and this is the integration. This is our area from a to b that has to be calculated. F of x is our function at y-axis, and our dx is our x-axis. But integration is more easy and more accurate to find the area. In the next lectures, we're gonna substitute some values to prove that integration is the best choice.